of you can check your books, it is there in your book. So we're talking about ethanoic acid. Ethanoic acid is nothing but acetic acid. And we have also spoken about the physical properties. We have also seen why it is called as a glacial acetic acid. See whether you have that in your textbook. Okay. Children, it's high time that you start revising this lesson, because if you don't revise, you'll forget whatever we have learned here. Why is it called as glacial acetic acid? What does this word glacial tell us? What is the melting point? Yeah, because it freezes at room temperature. So when the temperature begins to fall down at about 17 degrees Celsius, okay, acetic acid begins to freeze and it forms, it looks like ice. So that is why it is called as glacial acetic acid. I hope everybody has written it in your notebook. Yes, you have it? You have a mention to it. Yeah. And we have also started off with our chemical reactions. The first of the chemical reactions was esterification. Did you see that? So we have taken an acid. Look at the board, you will understand. What acid is this? This is your acetic acid. This is an acid. And you are reacting with an alcohol. Which alcohol have you taken? Which alcohol have you taken? You have written it down already. This is already over. I'm just brushing it out. Ethanol. So ethyl alcohol. C2H5OH. Okay. And also obviously it is in the presence of sulfuric acid. So what happens is there is a removal of water. Okay. Removal of water is what? There is one H here and there is an OH here. Okay. So if you remove an H from here, this becomes negatively charged and this will combine here. So what are we getting? CH3COO. Okay. And it will combine with this C2H5. Do you understand? These are like Lego blocks that children play. You take out block from one, you put the other block. That's exactly what is happening. C2H5. Did you see that? So this is an ester. So this group here is a functional group which is called as ester. Can all of you see that? Okay. So acid, look at the difference between an acid and an ester. An acid is COOH, whereas an ester is COO, and there's something else there. It's not an H. It could be C2H5 or whatever it is. How will you write this? You will write it as C double bond O and an H. Did you understand? How will you write an ester? It is very similar. COO without this H, there is another group, and this group is your C2H5, which we call it as an R dash. You see that? That happens to be an R group. R is something else. It could be something else. It's not an H. If you see the difference between these two, write it down. Write it down. It's not given in your textbook. Refer to these notes when you're studying for your exams or tests. Okay, it becomes easy for you to understand. So R, COOR, this happens to be your other group. That's your functional group, which is an ester. Okay. So how is an ester formed? What are the two things? You are taking an acid and you are taking an alcohol and you're, see the experiment, what are we doing? We are heating it up. So obviously there is heat which is involved in the presence of concentrated sulfuric acid. Okay. So this is a dehydration reaction. Dehydration means what? This water has been taken away, thus of course water. Okay, because water has been taken away. Did you understand? How can you make out that this ester has been formed? It has got a very distinct, nice smell. What type of a smell? It is a fruity smell. Okay, nice smell you have. And these are the esters which are used for, let us say, vanilla essence. You know, when you start cooking, baking, you use essence, no? Yes. Okay, so these are the different type of compounds. Each of these compounds has got a distinct odor. It has got a very nice fruity smell. Okay, so you can know that an ester has been formed. Did you see that? Look at the experiment which is given on page number 73. There's a picture there of an experiment. Burner, tripod stand, wire gauze, water beaker, test tube containing the reaction mixture. Why is it that we have taken the beaker and then we are putting our test tube which contains the reaction media? And then of course you are heating it on a tripod stand. Why can't we heat it up directly? Because it is starting? Which will start burning? Very good. Alcohol will catch fire. Correct? So you cannot heat it up directly. What you have to do is indirect heating. So you have to keep it in a water bath and then you have to heat it up. Is that okay? Put a star because this process, which is esterification, is a very, very common question which is going to be asked in your exams. Have you all followed? Suppose, did you follow? Don't look blank. Okay? If you don't understand any, once again I will explain. This one, this is the one. Have you followed here? If I take another alcohol instead of C2H5, suppose I am taking something else. So this group will change. Correct? This part of it will remain the same because you have taken acetic acid. So this is acetic acid to which whatever group of the alcohol is there, that is getting added. Is that okay? So it is an ethyl ester. Right? It is an ethyl ester or ethanoic acid also you can say. Right? Now let us see what is going to happen here. The next step or the next reaction that we are going to be talking about is what is known as saponification. Saponification. Okay? See the word soap. Something that sounds like a soap. Because the next process that we are talking about is how a soap can be manufactured. Okay? Soap is nothing but a long acid with a sodium. It's a sodium salt of an acid. Okay, so what do? We are starting with an ester and we are treating with sodium hydroxide. Here what did we treat it with? We have treated with an acid. Now if I am treating it with a sodium hydroxide, the reverse reaction will take place. You understand? Let's see what is going to happen. I am taking this ester, which happens to be CH3, COO, C2H5. What is this? This is an ester. Okay. Now we are going to treat it with sodium hydroxide. So what is going to happen here? This part of it will get broken up. C2H5CO. Yes. You have an Na here and you have got an OH. So the C2H5 OH will come here. CH3CO, which is the acid part of it, the Na part will come here. Correct? So when you write down complete the equation, you will get CH3COO Na आ जाएगा यहाँ Na आ गया. Okay. And whatever is left behind is C2H5. What is happening? OH is happening. So you are getting your ethyl alcohol back again and you are getting slight variation of the acid. What did we get here? It is not the acid that we have got, but it is the sodium salt of the acid. Sodium acetate. Did you all understand? Is it easy? So this process is what is known as saponification. Here, of course, this acid that we have taken is a very small acid. But if you take a long acid, okay, like for example C17, C15 or whatever it is, right? Then the sodium salt of such type of acids are used for the manufacture of soaps. So did you see that? Your organic chemistry is involved in everything that you are using. Soaps, detergents, chemicals that we are going to be using. Okay? So that is your saponification reaction. Please take it down. Saponification. First point. This process is, I'll give you a few points later. Saponification. This process is used in the preparation of soap. Second point. Soaps are sodium or potassium salt or potassium salt of long chain of long chain carboxylic acid of carboxylic acid. Soaps are sodium or potassium salts of long chain carboxylic acid. Now I'm going to explain this sentence once again. Look at the board. Okay. Acetic acid. What is the formula? CH3COOH. How many carbons do we have? One carbon, second carbon. Very short. We are talking about a long chain. What does it mean? More than about 16. So we are 1, 2, 3, 4, 5, 6, blah blah blah. Last में क्या आएगा? Carboxylic acid में क्या आएगा? COH. Did you understand what I'm saying? What is this? If your carbon is more than 16, it becomes a long chain carboxylic acid. Okay? Now what did I say? It is the sodium or potassium salt of long chain carboxylic acid. So instead of this H, we can have COO, Na, or we can have a COO, K. Sodium salt of carboxylic acid. यहाँ पे क्या नाम है?
Acid होता है, basic होता है.
Long chain of what acids? COH is our original acid.
एग्जाम में टेंशन भी आया था सॉल्ट का बेसिक वाला.
One minute. Let's go back to that afterwards. Any doubt in this? What have we taken? Yes, 1 minute. Or if you look here, 1 minute. Take 1 minute. Look at the book. We have taken an acid. Correct? What is a long chain acid? More than 16. So I've drawn so many carbons here. These are all carbons. Right? So what did we say? This is the sodium or potassium salt of a long chain carboxylic acid. Sancha, we take down this diagram for you to remember. That's all. You will forget it by the time the exam comes. Just make a note of it. Put dash just for you to understand that it is more than carbon. Last is what? COH. The H part of it is replaced by Na or it is replaced by K. K is potassium. Did you understand now? What is saponification? What is soap? So this is the formula for soap. What is soap? It is sodium or potassium salt of long chain acid. Okay, long chain acid. Clear? Okay. Did you write down this saponification? Yes, you. Sorry? Soaps are? Yes, they are basic because of the sodium salt has already come. This acid, why is it an acid? Because H is there. Okay, now it has been replaced by an Na. Therefore, the peptide acid. You have also reacted it with NaOH. Did you see that? So therefore, your soap are basic in nature. Did you write down saponification reaction, all of you? Have you written it down? So here we are not taking a very long acid. We are taking a short acid just to give you an idea. So you take an ester, you react it with sodium hydroxide, you get a sodium salt of the acid. Which acid is this? Acetic acid, sodium acetate, and of course you get your alcohol matter. Okay? Okay. Look at your textbook once again. So we have to go to the next page. You see the reaction, the presence of NaOH, how the ester is getting converted back again into an alcohol and it is getting converted into sodium salt of an acid. Got it? Now we come to the third reaction. What is the third reaction, tell us? Reaction with a base. That's simple. This part of it we have already done. What are we doing now? What is the heading now? We are studying about the chemical reactions of what? Of carbonic acid. Yes, of an acetic acid. So now the third reaction is very simple for us to understand. We are taking acetic acid, CH3COOH, and you are reacting with sodium hydroxide. Tell me what will happen? CH3CONA. What else is released? Water is released. So this will come here. Hydrogen will come on here, forms a water. So you have got CH3COO. Na is coming there. What else is released? The H and water. Take it down. Third reaction, very simple. Come on.
This is not happening.
Yeah, what is this? Where is it? This is what?
Sodium
Acetate. This is sodium acetate, formation of sodium acetate.
KCl basic one.
KCl, you're talking about K and Cl. Where did this K come from and where did this Cl come from? You're talking about acid and base here.
Yes,
Question.
ma'am.
Where did you get this HCl from? Cl is coming from HCl and this K is coming from KOH. This is a strong acid, this is a strong base.
Neutral sodium.
Okay, no cross talking here. Please finish taking it down. Quickly now. Ethanoic acid. Write down one line. Ethanoic acid reacts with a base like sodium hydroxide to give you a salt. What is this salt called? Sodium acetate, also known as sodium ethanoate. Okay. Did you notice that this is a typical acid-base reaction?
Yes.
Look at the board. This is an acid. This is a base. It forms a salt and water. So what is such type of reaction called?
Neutralization reaction.
Okay. So an acid like acetic acid also behaves like a typical acetic acid because it forms a salt and water. Rituraj, have you taken it down clearly in your book? Look at the textbook there. Did you get point number 3? Yes. Reaction with a base like mineral acids. Ethanoic acid also reacts with a base like sodium hydroxide to give us salt. In this case, we have taken sodium ethanoate, commonly called as sodium acetate. Here, where are we? Yeah, point number 3 there. And water. Did you notice? NaOH plus what? Acetic acid forms sodium acetate and water. Finished? That's clear? There's a small reaction. The next reaction below that activity 4.9. What will happen if you take an acid and you react it with sodium carbonate or with sodium bicarbonate? So the next reaction that we'll talk about is reaction of an acid with either a carbonate or a bicarbonate. What is carbonate? CO3. Bicarbonate is HCO3. Remember? What is sodium carbonate? Na2CO3. Sodium bicarbonate? NaSCO3. Okay. So whenever we have an acid like HCl, which is combining either with carbonate or with bicarbonate, which gas is given out? Nitrogen.
Hydrogen.
Why hydrogen?
CO2.
Carbonate से carbon dioxide आएगा. Okay, in both the cases it is carbon dioxide. What are you busy doing now?
Sodium bicarbonate is NaCO3.
Right?
Sodium hydrogen carbonate
Is also the same.
same, no?
Sodium bicarbonate or sodium hydrogen carbonate is the same. Yes. Are you clear about it now? Okay. So what is happening? In both the cases, you are getting carbon dioxide, effervescence is coming up, and of course water is formed. So it's the same reaction that we are talking about. Which acid are we talking about? Now we are not talking about HCl. We talk about acetic acid. Reacts with sodium carbonate. What will happen? This is a base. That is an acid. Forms salt and water. Okay?
That's H2O.
Very good.
CO2 will bane.
Yes. Carbon dioxide is there? No carbon there.
CH3CO Na.
CH3CO Na हो जाएगा. That is your salt.
Plus
Yes. Carbon dioxide gas is coming out and water is also formed. Come on, write down. Reaction of acetic acid with carbonates and bicarbonate or hydrogen carbonate. You can write anything. Reaction of acetic acid with carbonate and or hydrogen carbonate. So what will we get here? You will have CH3 COONA. That means one hydrogen is released from here, right? And we have got carbon dioxide. Of course, this is a gas, and then you are having H2O. Now look at the board. How do we balance it? Look at the board, everyone. H2O. That means two hydrogens have to be released. But if you look here, how many hydrogens? Only one. So I have to take two of that. So if I'm taking two of this, that means I'll get two of hydrogens. If that is at two, then obviously this is at two. Okay. So obviously there is two Na. So you will get two such molecules. So one nitrogen is sodium is going to be here. Balance it now, everyone. So what is important for us to remember is carbon dioxide in the form of gas, which is effervescence, okay, and of course water. Take down the next one. Similar to this, we'll also talk about bicarbonate. What will be the formula of bicarbonate or hydrogen carbonate?
NaHCO3.
Very good. NaHCO3. Same way you will have H is replaced by Na. Complete. What will you write here? Come on, tell me. CH3, COO, Na, and of course carbon dioxide and water. Come on, write it down. Did you notice that in both the cases, this part of it is the same? Okay, so this can be used as a test. Is it the same? Yes. Is it balanced? Is it balanced?
No.
2 hydrogen, no? So here only 1 hydrogen is released. So what happens? We need to take 2 of this, we need to take 2 of this, and also take 2 of this. Only 1. So no need at all. Hydrogen, there can be 2 of them.
So it will be like after.
1, COH, H and OH. It's balanced. Only 1 is. Okay?
Part hydrogen and
1, 2, 3, 4, 5, 6. 2, 4, 5. Oops, balanced. That's balanced. Look at the questions which is given in the box there. In-text questions. Okay. How would you distinguish experimentally between an alcohol and a carboxylic acid? What are we using here?
See.
What is this? Is it an acid? Is it an acid or is it an alcohol?
Acid.
It is an acid. When an acid is reacting with sodium carbonate or sodium bicarbonate, what is happening? Carbon dioxide bubbles are coming up. So in a test tube, if you are taking your acid, acetic acid, okay, and you are putting either carbonate or a bicarbonate, you will immediately form bubbles coming out. Okay, but with an alcohol, there won't be any such. So that is one of the distinguishing tests. Will you remember? Yes. Sorry. Yeah, I will take. Is that okay? Put a tick mark. Come on, write up. Quickly. Distinguishing test between alcohol and carboxylic acid. First point. Carboxylic acid like acetic acid. Carboxylic acid. How are you doing? Between alcohol and carboxylic acid. Okay. Carboxylic acid reacts with carbonates or hydrogen carbonate to form salt, carbon dioxide, and water. Okay. What happens with alcohol? No reaction. Okay. Second point we write, with alcohol there is no reaction. So immediately you can make out whether it is an acid or an alcohol. I very strongly advise you to go through this carbon and carbon compounds. Okay, plenty of questions, especially on page number. You have your MCQs. Take a note of it. This you are going to do it for homework. Okay, page number 127. Page number 127 of your volume. Correct? You have your MCQ. The moment we finish, now there's only a little part of it where we're talking about soap, action of soaps and detergents. Okay, you will be able to do most of the questions and it will be a thorough revision for your acids and alcohols. But do it over this weekend itself. That's all. That's what I'm saying. We'll be able to conclude our chemistry chapter. Okay, but there's one more class which I'll take a quick revision of this particular lesson.
So yeah, the British for the chapter by chemistry.
Everything, all four of them are equally placed. And you will have about 26 marks. Plenty of reactions in all the chapters.
People, so yeah, the
Very important. Organic chemistry is very, very and very scoring also. What is the discussion there? May I also join?
There's a question. Question paper like.
Okay, never mind. I'll talk to you regarding the question paper afterwards. Is that okay? Never mind. I will talk to you later. Boys, you heard what I said. Is that okay? Finish. So we are finished with the index question. Second question, what are oxidizing agent? Remember oxidation, reduction, oxidizing agent, what does it do? It provides oxygen.
I'm teaching for
So you have got your potassium nitrate, potassium permanganate, all of them are very powerful oxidizing agents. Now that we have talked about soaps, you will also realize that for the manufacture of soaps as well as detergent, okay, we are basically making use of organic chemistry, right? So once again, we talk about manufacture of soap. What did I say soap was? I give you a definition of a soap. What is a soap? Sodium or potassium salt of long chain of carboxylic acid. So that's exactly what we have to talk about. Okay. So you have a long chain. This is a very long chain. This is a hydrocarbon. Did you understand why we call it as a hydrocarbon? Because it contains only hydrogen and carbon here. Did you understand? Carbon and hydrogen. But last what comes? It is COOH. So these are long chain fatty acids. Why is it an acid? Because this is the functional group. Now what is happening here? This H part of it is replaced by what? It is Na or K. So it is the sodium salt of it. Acidic, not acetic acid. It's a long fatty acid. So how does it actually look? It looks something like this with a head here. This part of it. If this is removed, this is your positive and this is your negative. So you have your Na plus here. So this part of it is ionic. Did you make out why it is ionic? Because it has a charge. Whereas the hydrocarbon tail does not have any charge. So when we are talking about the action of a soap, basically what happens is a soap is required to remove any kind of a dirt from any surface material, maybe it's a cloth or a metal surface or whatever it is. So when you have got an oil or a grease or something of that sort, this is the dirt that has to be removed. We are using a soap. Okay. So what happens is you notice that the structure of a soap molecule consists of two distinct parts. One which is attracted towards water and the other part which is attracted towards the oil or the grease part. So if this is the dirt that has to be removed, the tail part of it will come and attach to that. Okay. Whereas this ionic part is getting attracted towards water molecules. Have you followed what I'm saying? Have you seen these cranes picking up things? Maybe on the TV or something of that sort. If there is an object which is lying here, what does a crane do? It comes and it picks it up. Now that's exactly what is happening in a soap molecule. So which part of it is getting hooked on? It is the tail part of it, which is the hydrocarbon. So the tail part of it is hooking on to the grease particle, and when you're washing it with water, this comes out in the form of foam. Did you understand? Here, is it okay? No. Foam, lather. When you are applying soap, basically what you have to do is you have to clean the cloth. Okay, you have to agitate it or you have to scrub it. So basically what happens is when you're scrubbing it out, this dirt particle which is present in the fabric is getting cleared out. Okay, so it is the hydrocarbon part of it which is getting which clings on it, folds onto the dirt particle. And you have this particle, that is the head part of the soapy particle, which is getting attracted towards the bottom. So when you're washing it out, along with the foam, the dirt particle is also removed. Okay, so we are going to use two words. Okay, this is hydrophilic. What philic? Philly is what? Liking. Okay. Phobia is what? Hating. Fear of. So this is hydrophilic end. Why do we call it as hydrophilic? Because it likes water. Which part of it? It is the head part of it which is liking water. Are you getting what I'm saying? Yes. Here, somebody will explain now what I said. What is the structure of a soap molecule? Very important question. Will be asked in all exams. Try to understand it now itself. What is a soap molecule? If you look at the diagram which they have given, how is it? It has a typical head and it has a tail like. Does it look like a tadpole?
Yes.
It's always called as a tadpole molecule, just for you to get an idea. Okay. Where is the charge? Is it the head or the tail? The head part of it. Okay, because it contains the COO negative and the sodium salt. Is that okay? What does the tail part consist of? What is it having?
Hydrocarbons.
Very good. It's only the hydrocarbon. These are the hydrocarbons of what? What is our original thing? What did we take this one? What acid? Any carboxylic acid. Okay. These are the acids which are present in oils or fats. So anything that's more than 16, 20, such long carboxylic acids we take, react it with sodium hydroxide, you get soap. When soap is once again used, this will be the action of soap or detergent. Is that okay? Right. Soaps and detergents. There's a very small diagram which they have given. There's a dirt part of it. And did you notice all the tails are towards the dirt particles? Did you notice that?
Oil.
Oh, oil is the dirt particle. So the heads are all away. Okay, so that is how it forms a micelle. This structure itself is what is known as a micelle. Micelle. Some people pronounce it as micelle or it is micelle. Whatever it is. Now what is happening? These are all the soap molecules. Hydrophilic and hydrophobic. This head part of it is getting attracted towards water. But what is taking? What hydrophilic? It's there in the text. It's there in the text. Okay, let's look at Abhishek. You read the activity part of it now.
4.1.
Yes. 4.1.
Take about
Pay attention. Where are we? Page number?
74.
Page 74. Ready?
Take about 10 ml of water, heat to test tube, add a drop of oil, cooking oil to both test tube and label them as A and B. To test tube B, add a few drops of soap solution. Now shake both the test tubes vigorously for the same period of time. Can you see the oil and water layers separately in both the test tubes immediately after you stop shaking them? Leave the test tubes undisturbed for some time and observe them. The oil layer separates out. In which test tube does this happen first?
You understand? What all have you taken? You have taken 10 ml of water in 2 of the test tubes. Imagine you're doing the experiment. I'm coming back once again to this. What is happening if you're putting soap and other things, okay? And next, what are we doing? We are adding a drop of oil. So the moment you take a test tube, you put water, you put oil. Will you find 2 separate layers? Yes, definitely. To one of the test tubes, you have added water and oil. To the other one, you also put water, oil. In addition, we have put soap also. Both the test tubes, you are shaking it up. Okay. Initially, when you see, you will definitely not find any difference. But in one of the test tubes, you have added soap. What happens in that case? Okay, it has already dissolved the grease part of it. But in a test tube where you don't have soap, once again you will find the difference, or you will find an oil layer and you will find the water layer. Is that okay? That will show you the action of soap. Why? Because the soap has already clung on to the grease particle or the oil particle and it has formed, wherein of course it forms a foam which can be. Is that clear? Yes? Okay. Read the next paragraph. This activity demonstrates.
This activity demonstrates the effect of soap in cleaning. Most dirt is oily in nature, and as you know, oil does not dissolve in water. The molecules of soap are sodium and potassium, salts of long chain carboxylic acid.
1 minute. What are soaps?
Long
Is it only long chain? It is sodium or potassium salt or underline. What is a soap molecule? What are soaps? Yes. Did you underline? Read.
The ionic end of soap interacts with water while the carbon chain interacts with oil. The soap
1 minute, 1 minute. Read each line very carefully. This part, the hydrocarbon chain, this reacts with what? What is this? Oil. And this part of it is reacting with what? Underline. When you are writing, the answers have to be very clear and very specific. Don't just write any rubbish there. Okay? So you need to mark it out. Get it? Underline this point. The ionic end of the soap. What is the ionic end? That is the head part of it. Okay? That is interacting with water. Whereas the carbon chain is the one which is interacting with the oil. Here, the soap molecules.
The ionic end of soap interacts with water while the carbon chain interacts with oil. The soap molecules thus forms a structure called micelles.
Okay. What is a micelle?
Soap molecules. Structure of soap molecules.
Structure of a soap molecule. It's incomplete. This is the structure of the soap molecule. What is a micelle? Dog with oil. Did you understand? This is a micelle. Look at the board, children. This tadpole structure is the soap. Soap is doing what? It is picking up the oil. So when it is picking up, it forms a small sphere around the.
That's fine.
Emulsification. It is picking up the dirt. No, not this. They have the same things. Okay, clear? So we are clear with what is a micelle. What is a micelle? Micelle is nothing but a 3D structure with many such soap molecules clinging onto the dirt or the oil which has to be removed. Continue. Yes.
Yes, like in exam.
In the exam, they will ask, explain the structure of the working of a soap
Ma'am,
molecule.
do we have to draw the diagram?
Okay, what is a big diagram there? What diagram? So easy. Just see, you just
But
Tail.
they ask.
why not? Or if they give you a diagram, you may be asked to identify what are the parts of the diagram. Have to label it. Continue.
The soap micelle helps in pulling out the dirt and water, and we can wash our clothes clean. Can you draw the structure of the micelle that would be formed if you dissolve soap and hydrocarbon?
Virat, Dekha, can you draw the structure? That means they are expecting you to draw the structure. Put a Q there. Okay. Now we are going to talk a little more regarding what is a micelle. Okay, micelle is nothing but a tadpole structure, which is nothing but a soap molecule which is getting attracted towards the dirt particle or the grease particle. Is that okay? Anybody from here? The soaps are
Hydrophilic.
Underline hydrophilic.
That is, it interacts with water, while the other end is hydrophobic.
Hydrophobic. So this part of it is away from the water. Therefore, this is hydrophobic. This part likes water. Therefore, it is hydrophilic. Now I'm stopping reading for some time. Quickly take down the structure in your book. Draw it properly, okay? Okay, this can be your COO-NA. And here is your oil or grease or whatever it is. So it has two distinct ends, hydrophobic end and a hydrophilic end. Boys, please do your work without talking. Finish class under COO. Okay, they are not given COO in the textbook. Did you notice it? They have not given, but I've drawn it for you to remember. Not exactly what we are discussing. Not really. It's quite simple. Basically, we have completed this part of it. Did you understand? So, if there is a grease or an oil substance, what part of the soap molecule is going towards the oil? It is the tail part of it. Tail part is what? It is the hydrocarbon. So, the hydrocarbon part of it is going towards the grease, and the head part of it, which is hydrophilic, is getting attracted towards the water molecule. So, that is how it is capable of taking away the grease particles. Okay. Continue, please.
When soap is at the surface of water, hydrophobic tail of soap will not be soluble in water, and soap will align along the surface of water with the ionic end in water. And the
Notice what part of it is in the water? What will be inside the water? This part of it will be inside the water because it likes water. Okay, whereas the tail part of it will be above the water. There.
What is hydrophilic? Sodium is hydrophilic.
This part. Read.
in water, and so hydrocarbon tail protrudes out of water.
So what happens to the tail? Boys, one minute. What's wrong? Boys, what's wrong? Move there. Wait. Move there. There. What's the discussion now? So important. See.
Inside water, these molecules have a unique orientation that keeps the hydrocarbon portion out of water. Thus, structure of molecules in which the hydrophobic tails are in the interior of the cluster and the ionic ends are on the surface of the cluster.
Okay, stop. Read that sentence very carefully. Which part, where, what is happening? Each one of you will read very carefully because I'm going to ask you questions now. That is telling you how the soap molecule is reacting. Action of the soap molecule. Important question. You will write this for homework and come for the next class. Next Friday will be a review of this carbon and carbon compounds along with the questions. Are you listening?
Yes.
MCQs to be completed. You will revise and this answer you will write and come. what is the action of the soap molecule. Got it?
Yes.
Remember what I told you for physics? Wednesday we have a class on what was it? Human eye.
You must be able to write a definition.
That I don't know, that you remember. I'm just reminding you, that's all. There were many who did not do it. Yeah, now what was the question? What was the question? Some question in your test paper or something.
वो बहुत सारे डाउट है ना ये दिखा ना रात्रि छोटे छोटे
नहीं है मेरे पास।
अभी
Oh, the rest of but I think
बाकी सारी लास्ट में ऐसे
इजी था आज कॉलेज के मुझे लास्ट फर्स्ट
अरे तू तो वेट कर रहा था ना बाहर
and why no one will wait down और किसने फॉर्म नहीं भरा बैंक से निकालना भाई अरे मेरे को दे
बट्टी
नहीं निकाल कर
Rajti has gone. Hey, this one, Rituraj, you wake up. Don't disappear. Your school exam, you have only one chapter, 2 chapters.
हमें और एक्सप्लेन एड्रेस
You are looking through your chapter for content to go into it. Achha, now it is going on. Once the exam is over, you have to keep revising. That goes for everybody. ठीक है? चल.
फिलिंग की फॉर्म जैसा लग रहा है कि तुम क्या कर रहे हो आप इतने डर डर के क्यों फॉर्म भर रहे हो थोड़ा बिंदास रहो
No, in all other things it's very bindas.
see
हाँ.
from when he is taking the form and stop filling it या अभी देने का कभी देने का कभी ऐसा बार में घुस जाएगा दीवार में चले घर पे रोटी क्यों बात जाओ घर पे कोई रुकेगा नहीं कमन बस मुंह
Rituraj, don't disappear. I want to talk to you.
ना बेटा चल मान में पापा आ गया सिखा ली अभी फोन के नहीं मारा नहीं लगे इसको भर नहीं जा परसेंट क्या है
हो गया
20% क्या है
90 का परसेंट ले रहा है सच में
ऑफिस में मतलब किसी रेट में ना
चल हो गया ना देख लो
ऐसे लगता है क्या
आगे पापा क्या कर रहा है
Bagadan.
बैठ रास्ते
एक मिनट रुकना उसको
व्हाट्सएप नंबर किसका तो व्हाट्सएप नंबर लिख दे एक्सपेक्टेड
मेरा तो व्हाट्सएप नंबर है दिखाई नहीं
देखो
क्या करने जा रहे हैं
ये
ऑफिस एड्रेस लिखना जरूरी है
पड़ेगा
इसे कुछ लिखना नहीं ना
इस पे क्या लिखा है मुझे लिखना ना
ये वाह ये नाम लेंगे लोग तुम लोग को एक करोड़ चाहिए ना चाहिए कि नहीं चाहिए
नहीं
चलना